Health Passport is for those with dementia and learning disabilities. This is a portable little handheld device that will collect information about what your preferences are, what you like and dislike, but also visual evidence. So we need to have a micro camera as part of this embedded system. We have all of these hardware parts. They need to be put together. A device needs to be designed that can be given to a mental care patient. Okay? This is again for the NHS Trust. Cardio Pointer is for the UCL Heart Hospital just down the road. And they have a really nice system where we want to be able to visualize merged 3D scans. How many of you heard of an Oculus Rift? A few of you. This is a virtual reality headset for a surgeon to be able to articulate the pathway in which they're going to do their operation. Currently, they take the MRI scans and using Cartesian DICOM format, they get a rough approximation of where things are in a real 3D space. They can spin it around. But now they want to actually visualize inside of it. They want to navigate through it. And there is another attached project that several master's students will be joining to get exact measurements with a 3D depth scanner. Hopefully an ARM platform that will be powering this depth scanner will say from the incision point inside the heart to the particular defect, how far is the distance, right? So how many of you have ever used a Kinect? Okay, a few of you, not that many Xbox players. So you're basically going to be programming a micro Kinect to capture this depth information. Cardio Trainer is a little bit more software based, but essentially we need motion tracking and we need motion recording. As we do a surgery, as 4 surgeons are working in a team, they want to be able to capture particular things that they're doing. So how are we going to track that? We can film them, we can take their audio capture, we can take particular motions that they're gesturing, right? Those motions in time, if you look through a timeline and go scrolling through a timeline, they might actually mean something. They might say at this critical point, when this blood vessel needs to be tied, this is the motion that you need to enact. We can then send that as training data, as 3-dimensional vector data that other surgeons can make use of. There are a number of software projects on this list. I'm just going through them. If you feel this is too long, I can speed it up. But this one is a more software-based one, where if you imagine that you're a business manager or you're an entrepreneur, you're just starting up a company, and you want to make a business pitch, what sensors could you make use of that can let you put down products and identify them? So maybe you've got RFIDs, maybe you've got particular tags or QR codes. You would note what objects you've got, and it will automatically find reference material about it. So, can you give me an example of an experiment that they might be running?
Instrumentation.
Okay, so an instrumentation experiment. Mm-hmm. You have this experiment. What kind of references would you want to populate around that idea?
What, in terms of inputs or?
Yeah, sure. Any information.
So strain gauges are their input signals. So they're collecting the analog data from the strain gauges,
right,
as voltages.
So it'll give you some diagnostics. It'll give you some information. It'll give you limits. It'll give you reference material to do with this object. Right? The extrapolation of tangible objects into the real world. This is a project sponsored by Microsoft because they had a table. It was originally called Surface, which is now something else. It's now a tablet. But the Surface table, the original Surface table, we have one in computer science, and it had a camera in it, and as you put things down on it, it would let you find out some information about it. This is about constructing models of real-world objects and what information domains surround it. Yeah? So if it is an experimental object, you put it down. If it's something radioactive, it tells you about the information about it, whatever. There are information that relates to that particular object that you put down. Near-share from Microsoft Research. If you have near-field communications, NFC tags, if you have your PDA and you have a tablet, you put it next to it. For the computer to realize that the two things are next to each other, we need to do some triangulation. Okay? And currently, there is a system on Apple, which Microsoft aren't very happy about, that lets you share the screen. What Microsoft want you to be able to do is to be able to copy and paste data from the screen. But for EE students to come on board, this will be about getting the accelerometer data and then NFC data and doing the triangulation through wireless frequencies of where is this thing placed around your computer. So if I walk past several different computers in this lab, I should be able to extend the screen of each one of those screens. Okay? There might be a few blank looks of like, what the hell? But I can take it for granted. You have people at Microsoft Research who will be helping you on this. You have computer science students who will be working with you on this. And this is for you to design experimentally as a proof of concept. How would you envisage getting this done? UCL Chemistry have just developed a meth sensor. For those of you who have been watching Breaking Bad. The Metropolitan Police would like to have a mobile device. And essentially they found that pseudoephedrine conversion into meth happens quite frequently in hotels. So the actual manufacturing of meth, they want a detector that they can walk around hotels and get signal strength of this this material. So you'd be designing a hardware-based device. Maybe you have it over USB, you plug it into your phone. The app runs on your phone, but the sensor, that will be for the Fleming Society to design. How do you get from the chemistry sensor the signals needed to give you the concentration strength and pass that as digital data to the mobile device? You literally are going to build the world's first meth detectors. Okay. We have a robot. We have a hovercraft that will have smart skin, and it should be low radar intensive. And we're going to build a motion guidance system, and the prototype will have 3D printed skin. But essentially, we need you to help out with mechanical engineering to help design the control systems for this. Okay? Our software engineers have already been working on robotics with regards to the capturing the data and optimizing algorithms like what data for wall following, etc. But this robotic hovercraft is meant to go down into sewers. We can plug in a depth camera and it can search for weapons and knives. The Met Police would like to see this as a proof of concept. Professor Steve Hales, who works on sensors in computer science, has been working on a new design for air control flow. So mechanical engineering will be assisting him to design the air mechanics of how this robot will work. We have several Oculus Rifts. We have Leap Motion devices. These let you gesture on screens. We would like to augment them with other sensors. There might be particular students here that might want to do motion tracking or any ideas you might have for other types of sensors that can realize, maybe even audio sensors, what that means when you input that into a 3D canvas when you're actually surrounded. So if you're yelling for help because you're playing Doom 3 and you're actually inside the Doom 3 environment and there's creepy crawlies coming behind you and you're screaming that way, do they run away? Well, we need to know what sensors could you augment with this reality. The virtual reality environment is now a new enough area. What was previously developed now is a lot more sensitive and realizable. Lorna Wall, as I mentioned, worked for Sony, and we know that Sony are working on their own implementation of the Oculus Rift. So they want to see what platforms, what sensors could you imagine that you can combine with for the PlayStation and for Xbox. HydroChat. HydroChat is, imagine Skype on steroids. If you have every single screen becoming a Skype panel, that you can have motion gestures. As you lean in on a screen, it means I only want to talk to that screen. Yeah? Now, if you're in a boardroom and you've got several screens up on the wall and they're all different people from around the world, you're talking about your project, you're illustrating things on a virtual canvas, maybe you've got a light pen or some kind of pen notation. Each different panel represents a different communication. We need to be able to isolate the voice for each person and to adapt them to the overall conversation. When are we talking in a group? When are we talking one-to-one? So we're going to need some audio detection and audio filtering. I can tell you, I was at the Imagine Cup this year in Russia, and a team from Taiwan, they had developed on regular TV sets, the processors were fast enough to compensate for audio loss for hearing aids. So they can look at the frequency range of hearing aids, and they can map it to a Bluetooth receiver. and it was fast enough. As the TV was talking, it was transmitting it fast enough from the TV to the Bluetooth headset. What it meant was that the market for deaf receivers will drop dramatically with these TVs. You can actually just use a regular Bluetooth headset. The same idea. We want to have Skype canvases you can talk to in real time and separate when we're talking individually and when we're talking in groups.